Let's start. I want to present you today talk about IoT in monitoring some anesthesia practices, so in a medical environment. I'm a PhD student at EPFL in Lausanne, which is offering very nice panorama in nature. Therefore, we are doing a lot of activities like hiking and ski, but we are also working, of course. And this work that I'm going to present today, it's it rise from collaboration with some students that are master students that were under my responsibility. And there is Thibaut, Nadia, and Eleonora. So what we are doing in our research field is about personalized medicine. So we are actually searching for the correct treatment to give to every person in order to have the best efficacy of a medicine, in order to provide less side effects and to have the best output from this. And the effort we are doing here is to combine this concept with the concept of Internet of Things. So this new paradigm that is now having more place that connects everything to the internet and allows the different devices to be connected and to reach all the information every time and from every place. These two concepts together are offering something which is very beneficial because it's offering some monitoring systems, monitoring architecture that improve the patient care and the treatment's output. And it's also offering a tool for the medical doctor and the medical staff to have a better understanding of the status of the patient. So the benefit that the IoT can introduce in healthcare are a lot. So you can reduce costs without, in any case, reduce the caring of the patients because you're offering a continuous monitoring, even in remote mode. And you can also program their device, their equipment in remote, so you can control even maybe dosages or something like that. And you can share whatever kind of data because it allows interoperability different mobile. And early diagnostic is also feasible because if you can have always connected, always under control the parameter of a patient, you can even see if an emergency case is happening. And of course, it's also possible to offer prompt decision because the doctor or the medical staff is having under control all the data of the patient. So it can have a complete panorama of his health status. And what I want to say more is that probably our research is also going in the right direction because it was supposed to have, it was estimated to have an investment of $100 billion between 2012 and 2020. So actually we are going into the right direction with our research. This increase in IoT in healthcare is based also on some technologies which are developing. It's very well known that new wearable smart sensors are now available, like, for example, tattoo sensors, contact lens sensors, and also bracelet to track your activities. And this continued discovery of new sensors, which are very comfortable to be worn, and then the patient can continue to doing their activity, but all the parameters are under control continuously. Then there is, of course, the improvement in the technologies, which are becoming more and more powerful with costs that are in any case achievable. Then the need for telemedicine, because actually it's very important to provide the support also in that countries where are underdeveloped or rural, and maybe the specialists are in any case few and not sufficient to supply all the needs. Then there is the data analysis processes that are becoming more and more large and powerful, which is very important to handle all the big data that are produced normally in this kind of IoT architectures. All these technologies together are paving the way towards the concept of smart hospital. Smart hospital is an environment which is becoming reality, where all the devices and gadgets from medical staff is becoming to be connected and to interoperate together. So we have an interconnected environment, smart, because it can share data from the health status of the patient, but in the respect of the security and the privacy. So the outline of this presentation will follow, let's say, this list. First of all, I would like to remember last year in Droidcon, because I was here presenting another architecture based on a smartwatch, and I like to recall it because since we are a research team, every step we are presenting is based on something we have done before. So we are following like a line. Then I want to enhance why it's so important to provide monitoring during medical practices. So I will show you the case study of anesthesia, which was the topic of my PhD. I will show you then the new architecture, IoT, for monitoring of patients based on cloud. We have used Priv middleware solution, and I will show you the workflow we have implemented, the application, and the protocols used. Some pillars code will also be provided, and also the open source demo will be shared with you. And we will speak about validation and conclusion. So last year, as I was saying, there was a network based on a smartwatch. So the doctor was wearing the smartwatch, having a dedicated application in Android Wear 1.0, because it was still that available. And it was communicating with the patient connected to the network. We could have different clients connected, and every patient was connected to an Android application as well. Interacting directly with the device, which was measuring the parameter of the patient, the physical ones. And then there was a server application in the middle, which was enabling the bidirectional communication with the smartwatch and the multiple clients, because instead, in fact, it was in Android Wear 1.0, so the smartwatch could be paired only with one tablet. And to enable the bidirectional communication with multiple clients was important to have this bridge. So the main feature of this architecture were the request of parameter. So actually the doctor could choose among the patient connected to the network and required some parameter. Here, for example, is the glucose, temperature, and pH, because our device that we realized also the hardware was providing this information, but of course it's custom. Then it was providing an alert in case of out-of-range parameters. So in case one of these parameters was going through the threshold considered physical healthy, it was giving an alert. All this was applied for sedation, which is very important, and spread activity medical application. That is used both for surgery, but also for intensive care unit to keep calm the patient. To reach the anesthesia, you have to provide 3 main compounds in the cocktail, which are the anesthetic, like propofol, that is the most used, and is acting on the brain, and the patient is slept thanks to this. Then there is the analgesic to prevent the patient to feel pain. Here is written paracetamol, which is the best known here, but also fentanyl is largely used, which is an opioid. And then there is muscle relaxant, like midazolam, which make the patient immobilized for all the time of the surgery or during the critical moment in intensive care units. So all these compounds need to be rightly balanced and rightly dosed on the base of the patient, which is under anesthesia, because if too little anesthesia is provided, what happens is that the patient might feel still pain, but it's immobilized, so cannot give an alarm. Or it can have experience of awareness, so it would have some problem in the psyche of the patient after. Then there is, if you give too much anesthesia, you can have from the sickness of the patient after to the brain damages and to the most serious, but likely the less often, the death of the patient. The percentage is in any case high of this to under and over dosage. And that's why it's very important to provide a correct and personalized dosage of these anesthetic compounds all the time, and to provide the monitoring continuously for all the patients. So nowadays, just to let you understand what is missing, is use the target control infusion pump that implements some pharmacokinetic models of the drug specific that is infused in the patient. And you just have to insert some physical parameter of the patient, like weight, gender, height, age. And on the basis of that, a model is created, and the drug is infused dynamically to the patient accordingly to the model. And the anesthesiologists keep under control continuously the bispectral index, which is an additional parameter provided that is evaluated by the electroencephalogram signal, so the wave of our brain, which is correlated with the depth of anesthesia of the patient. However, both of these technologies are not providing a, let's say, reliable way of dosing enough, because the mathematical model cannot reproduce the interpatient variability in metabolism because it's mathematics, and the bispectral index is evaluated in indirect way, so it's not reliable because it can be affected by artifacts. So what we want to provide, so what we are working for, is to create a feedback in the actual scenario of anesthesia, to provide an online continuous monitoring of the patient concentration of the drug inside the patient, and to correct the TCI model with a real value measured in the patient's blood. This is the big picture of the project I have worked on during my PhD. I want to show you all the parts it's composed, because my PhD is now ending, so let's say the big picture is available. You have the electrochemical sensing platform, which is directly detecting the drug inside the blood of the patient. And to provide the electrochemical measurement, you need also electronic. This electronic is based on Raspberry Pi, and it allows you to do the measurement and to collect the signal to then evaluate the concentration of the drugs. Then, in fact, there is the target control infusion pump, which is provided with the concentration level of the drugs. And according to this, it evaluates the dosage to give to the patient with a real value this time. And then there is, on the top, an Android-based monitoring architecture, which is based on Android application and on Priv cloud support. Of course, the topic of this presentation will go deep on these two last points. So we have used Priv solution, which is a company born from a startup in Innovation Park of a PFL. And they provide a secure and private storage of the data and sharing of the data. They also allow a visualization tool online, and they allow to use different kind of data, so they enable interoperability. And they provide also open source tools in order to customize your solution and to dedicate it to your specific application. The data, which are called events in Priv, are organized in a modular and hierarchical structure. And they are characterized from a context, which are based on streams, substreams, and tags. And you can create your structure depending on the user needs or depending on the application needs. In our case, we have followed the application needs. Here, I don't know what happened. No, perché? Sorry. I have a problem. Senti, aspetta. Non riesco neanche più a farlo andare.
Ok, guarda, facciamo così. Vedi qua, ok.
Ah, ok. Grazie. Forse. Sorry for the interruption. However, I was speaking about the structure. We have organized on cloud to store our events, our data. So we have follow a structure which was used for our application. So the patient account was organized in stream, 4 streams, one for the personal data and one for each drug we were keeping under control. Then there were substream. Here are just the specific name of the electrochemical techniques we were using to detect them, which are different. And then there are the events, which are the real data measured from our system. For realizing of this, the realization of this architecture, we have supposed a scenario like this. We have 2 surgery rooms, one with an anesthetized patient each. Then there is the anesthesiologist in role that has to control both, and the PRIV cloud. One of the possibility was to send by the Raspberry Pi the data to the cloud, and then to send in parallel also to the tablet. But this was a bit heavy for the therapeutic drug monitoring system to be followed. Then another architecture we have thought was to send the data directly in PRIV, and then to push back the data on the Android application after. But also in this case, we were relying too much on the PRIV support. So finally, we have decided to implement this structure. So we were sending the data from Raspberry Pi to the tablet of the anesthesiologist. And from there, the anesthesiologist could choose if sending also to the cloud or not. And if shared also on cloud, also in remote, other specialists could have access to the PRIV account and online monitor all the data and, let's say, the trend of the patient. In this way, we are enabling telemedicine and teleconsulting. So if we see the main actors of this architecture, we have implemented some workflows to make this architecture work properly. From the point of view of the patient, to make everything set, the patient has to create or log in the account of PRIV, and it has to create a partition of its account to be shared with the patient to store the data during its surgery. So when he creates this shared partition of his account, an email is sent to the doctor in order to notify the doctor about this sharing. Then there is the surgery, and at the end of the surgery, the patient can even block and revoke the sharing with the doctor. From the doctor workflow, we have, again, the need to create or log in the PRIV account. And then, since he received the email from the patient, he can just click on the link that redirects him directly in the shared part of PRIV account. And it takes and store the credential to access this shared part, which are a username and a token. And then the rest of its workflow is handled by an Android application dedicated. So actually, the doctor can log in the application in order to protect the access to people not allowed to monitor the patient. Then we have an activity where you can fill all the data of the patient, and if the doctor wants and he got the access from the patient, he can share the data also in cloud. Then at that point, he has also to access the PRIV account. At this point, it's the time to connect with the therapeutic drug monitoring system, which is based, as I said, on a Raspberry Pi. So you can connect through Wi-Fi to this Raspberry Pi. So let's choose the first one. And you have connected your device to the system, and you are enabled now to start the measurement. When the measurements are start, you have the data which are received and visualized immediately on the screen of the tablet. And the data are exchanged with this protocol. So you have a start byte, then you have 4 bytes for the information, and finally you have a stop byte to conclude the package. And of course, we are also storing all the data in local with Excel file. And since we have enabled the sharing with PRIV, we are also sending the data on the PRIV account. Further, we have just implemented a notification in case of a parameter going out of the safe range. So it's just having a pop-up with the name and a vibration on the smartwatch of the anesthesiologist to have a prompt intervention. Finally, from remote point of view of the doctor, he also has to access or create a PRIV account, of course. And from there, he has a list. I don't know what now. Okay. He has a list of patients that he can choose among, and they are shared. And from there, you can click and see online the data which are stored from the patient itself. To create this architecture, we have implemented, first of all, a list of patients which are connected to the network, because, of course, we are speaking about multiple patients connected. And this list has to be shared through all the activity of your Android app. And here, there is all the interaction with the PRIV cloud. The QR code is redirecting, if you want, to the web page of PRIV, where there are all the demo and the open source code to be used for your application. And first of all, of course, you have to create the connection with PRIV account, creating the credentials, which are based on a username and a token, as I said before. Then you have to create, as we said, it's an event, the data is saved on a stream, so you have to create a stream. Before, to create a stream, you have to provide an ID and a name. And then you can create your event. You can also do substreams, but it's the same of a stream. And then the event. The event, you have also to specify which kind of event, so which kind of data are you storing. Because, as I said, it's it allows different kind of data to be stored and shared. Then you can get an event. To do that, you have to create a container and a filter in order to filter out all the data that you really want. And the same is also for the stream, apart from some changes in the code. So here I have reported an example of our application, which in my opinion is the most important method. It's to retrieve the sharing. So it's how to get the credential of the partition of the patient when to save the data there during the surgery. So actually, after you have set the connection and create the filter to get the last 10 patients so that the doctor can choose, you have to create to override the cache callback. And there you collect and you get all the objects as JSON object, and you can actually take the username and token of the patient. So you are now allowed to enter in the private part of the sharing. As concerning the system validation, of course, we are setting the setup in our laboratory because we want to test. We have used a tablet based on Lollipop for the anesthesiologist, also our smartwatch, but just for the pushing the alert. Then Raspberry Pi is simulating the target therapeutic drug monitoring system with the data, and a laptop to access the web application for the remote monitoring. From the point of view of the Raspberry Pi system, we have validated the receiving of commands from the application of the doctor, the sending of the parameter measure stuff to the doctor. Then the application of the doctor, we have validated the simultaneous connection with the clients and with the PRIV, and also the storing of the data on Excel file. And we have seen if multiple patients could be connected to the network simultaneously, and also the alert receiving. And from the web application point of view, we have instead validated the access of the patient, the possibility to share the partition of the account and to revoke this sharing, the receiving of the email from point of view of the patient. We have also shown the visualization and receiving of the data correctly online. And we have evaluated the latency on the creation of an event that is a normal HTTP connection. As concerning the flexibility of the sensor, I'm proud to say that this on-the-top cloud system, it can be really flexible because whatever sensor or medical device that is able to provide the data in a wireless manner can be connected to the network, and therefore we can measure whatever compound, endogenous and exogenous, and to be able to provide this monitoring to whatever application medical. The only thing that is required is to create a custom client application for the doctor, because of course it has to provide all the features needed for the application. So this is providing flexibility of our system. So in conclusion, we have seen an advanced IoT cloud-based system for monitoring medical practices. In our case, I provide the example of anesthesia to make understand how important it is in medical environment. Then we have seen the Android application, which we have called Uncontrol, anesthesia control, for the anesthesiologist tablet. Is the main actor of this architecture because it handles the connection with the Raspberry Pi and with the Priv architecture. It allows immediate visualization of the data and push an alert in case of an emergency. Then we have seen the web app application as a backend solution for storing the data and sharing them online. In this way, it's the doctor he can perform different tasks in parallel without losing the control over the patient under the responsibility, and providing, of course, also support in case of an emergency. And furthermore, we have enabled teleconsulting and telemedicine, thanks to the IoT, thanks to the cloud support of Prism. So I thank you all for your attention. I don't know how it works for questions, but I'm very happy if you have some.